Hello students, welcome to Lucky Learning. Here in this video, I am going to discuss extendable hashing technique. Before I start, what is extendable hashing? We'll talk about some points related to static hashing. In static hashing, when we have to insert any new data entry into a full bucket, means if the bucket is already full, right? And then if you have to insert new entry, what we have to do, we have to add an overflow page. So overflow pages are to be added. If you do not want to add any overflow pages, what was the solution? It has to reorganize the file at this point by doubling the number of buckets. Suppose here we have a 2 buckets. What we have to do, we have to make it 4 buckets. We have to double the number of buckets, and whatever the key values are there, all the key values requires to be redistributed across the 4 buckets. Means if n buckets are there initially, doubling causes 2n buckets, and whatever the key values are there, all these key values are to be redistributed. This solution is suffering from one major defect. What is the defect? The entire file has to be read and twice as many pages have to be written to achieve the reorganization of the file. It is a time consuming process. Because of this time consuming process, what was a solution? The solution is to use extendable hashing. Means this problem, however, can be covered by the simple idea using extendable hashing. In extendable hashing, we have to use a directory of pointers to buckets. Means these are the buckets, right? And these buckets will have a directory of a pointers. These are the pointers. Each directory of a pointer pointing to one of the buckets, right? It is going to point to one of the buckets. And double the size of the number of buckets by doubling just the directory and splitting only the bucket that need to be overflowed. Suppose if this bucket is to be splitted, assuming this is a bucket A, this is a bucket B. If this bucket A is to be splitted, I can have 2 buckets. Like I can call it as a bucket 1 and it is called bucket 2. Now totally how many buckets became? Now already 2 were there. Now splitting the bucket A causes bucket A1 and bucket A2. Total number of buckets are 3. Now the directory of pointers only 2 have, but only 2 is sufficient? No. Then what we can do? We have to double the directory of the pointers. If we double the directory of pointers, doubling directory will be less cost effective instead of doubling the number of buckets. And what we have to do, directory is going to be doubled, and whichever the bucket is to be splitted, only that particular bucket is to be splitted. Means if bucket is overflow, only overflow bucket is splitted. So it means directory is always smaller than the file. Because it is smaller than the file, doubling is much cheaper. So only one page of data entries is to be splitted. Means only that particular bucket is to be splitted, and that is causes overflow. Now we will discuss more about this extendable hashing with respect to an example. Here you can look the data pages and directory of a pointers in extendable hashing. Here this is a structure, shows 4 buckets, bucket A, B, C and D, and each bucket is capable to store 4 key values. Because 4 buckets are there, to differentiate which bucket hold the required key, we have the directory of 4 pointers. We have a directory of 4 pointers, and each pointer is represented with a binary number 0001 1011, and this directory consists of array of size 4, and with each element being a pointer to a bucket. So each element is pointing to one of the bucket. This is 00 pointing to bucket A, 01 pointing to bucket B, 10 pointing to bucket C, and 11 pointing to bucket D. Here, over the buckets, we have some number, and this number is called local depth. And over the directory of a pointers also, some number is there. This number is called global depth. Now we'll understand what is a local depth and global depth. And global depth of a directory, it is a meaning that the maximum number of bits, needed to tell which bucket an entry belongs to. So means, suppose I have an entry 21. If I have an entry 21, now 21 bucket, sorry, 21 entry is in the bucket B. Now this 21, if it is to locate, it has to see the two least significant bits of this 21, because the depth of directory pointer is 2, so that when 21 convert into binary, so how it can be converted into binary? 1 0 1 0 1, correct now? This is a binary equivalent of 21. In the least significant 2 bits are 0 1. It is a meaning that 21 should be in one of the bucket that has a directory pointer 0 1. How it knows that 0 1 is the directory pointers? Because the local depth is 2, and here global depth is 2. Actually here global depth is 2. This global depth will determine in which bucket it has to go. And local depth of a bucket, see, look at what is that local depth of a bucket? Number of bucket, number of bits used to determine if an entry belongs to this bucket or not. So here, if I have to look for 21, then the least significant 2 bits are the global depth will determine it is going into which bucket. And here local depth, here local depth is having 2 bits. Again, these 2 bits will tell whether it will go into that particular bucket or not. And maybe you are shocking, sir, local depth and global depth both are same. If because both are same, we use the same number of 2 bits for identifying in which bucket using the directory pointers. Whether that key value is there in the local bucket or not, we will decide based on the 2 only. Suppose if the global depth is 3, if the global depth is 3, means the least significant 3 bits will be used to know which bucket the key value belongs to. And if the local depth of that key, that bucket is 2, then only 2 bits are used to verify that key is there in that particular bucket or not. It is not mandatory that local depth and global depth is always same. But initially, local depth and global depth both should be same. And now if I have to search for a key value, and searching is to locate any data entry. To locate any data entry, we apply a hash function to the search key field. Let us say an example, we have to search for key 5. If I have to search for key 5. Now key 5 we have to represent in binary as 101, correct? 101. What is a global depth 2? It means least significant 2 bits are used to identify the bucket in which key 5 is maybe available. Now 01 is the directory pointer pointing to bucket B, so that next it has to see what is the local depth. Local depth is also 2. It means that 01 is the 2 bit, least significant 2 bits are belonging to the same bucket, and the key 5 is found. So means what it is doing, to locate any data entry, it applies a hash function. Here the hash function uses representing a number or representing a key in binary. That is a hash function. And to search for the field and take the last 2 bits, we call global depth of its binary representation to get a number between 0 and 3. So last least significant 2 bits are 0 1, representing a decimal number 1. It is a meaning that it is available in the pointer pointed by directory pointer 1. The pointer in this array position gives us the desired bucket. Now here in this case, what is the desired bucket? Bucket B. We assume that each bucket can hold 4 data entries. Therefore, to locate the data entry with hash value 5, so that is binary 101, we look at the directory element 01 and follow the pointer to the data page to locate that particular key value. And just I'm asking you to locate 32, what you have to do? 32 you have to represent in binary. So 32 in binary means like how many zeros? How many zeros? 5 zeros. Now what is the 2 least significant bits? 0 0. It means decimal equivalent is 0. Means it is available. 32 is available in the directory pointer pointed by 0 0. Go to this bucket A. Here we can find 32. This is how search will be done. Then we'll discuss about insertion. Suppose if I have to insert some key value 13. How 13 is to be inserted? First, we have to apply the hash function. What is a hash function here? Representing the key value in binary. So the key value in binary will be saying that 1101. Now what is a global depth? Global depth says 2 bits. So least 2 significant bits it has to check. That is 01. Now it means that 13 should go into a bucket whose directory pointer is 01. Now that is bucket B. So that 13 should go into the bucket B. In bucket B, one empty slot is there, so that this 13 will be placed in that empty slot. Here, some points for you to read. To insert a data entry, we search to find the appropriate bucket. For example, to insert a data entry with hash value 13, we examine directory element 01, which is the least significant of 2 bits, and go to the page containing 1521, that is bucket B. Since page has space for additional data entry, we are done and insert the entry 13. This is how insertion done. But here one point to be noted, because the bucket has empty slot, then insertion is done. Suppose if you have to insert into some bucket where the empty slot is not there, means we are trying to insert into the full bucket. Let us say into bucket A we have to insert. What we have to do? Let me give an example. Suppose if I have to insert 20. If I have to insert 20, apply the hash function. Hash function requires the key value to be represented in binary. So 20 we have to represent as 10100, right? 10100. Now what is the local depth 2? Means it has to use least significant 2 bits. That least significant 2 bits is required because global depth is 2. Then 20 should go into a bucket whose directory pointer is 00. Now this directory pointer 00 pointing to bucket A. It is pointing to bucket A. But do we have any empty slot in the bucket A? No, there is no empty slot in the bucket A. Means it causes an overflow. If it causes an overflow, it requires to split this bucket A into two buckets. Bucket A and bucket A split image we call. And the key values 4, 12, 32, 16 and the new key value 20, all 5 key values are going to be distributed between bucket A and bucket A's split image. It means the number of buckets are going to be increased to 5. When the number of buckets are increased to 5, this directory containing only 4 pointers, now these directory of a pointers are not suitable. If the directory pointers are not suitable, then what we have to use? We have to go with doubling the directory. Okay, if you double the directory, what happens? Actually, when you insert 20, what happens? The number of buckets became 5. But how many directory pointers are there? 4. But 4 can point to 4 buckets only. How do you point fifth bucket? This is not possible using directory of 4 pointers. Then we have to go with doubling the directory. Here you look at some sentences for your reference. Consider the insertion of data entry 20, that is 10100, looking at the directory element 00, that is least 2 significant bits because global depth is 2. We are lead to bucket A, which is already full. We must first split the bucket by allocating new bucket. So this is bucket A, this is bucket A2. We call it as a split image of bucket A2. So how many key values are there? 4, 12, 32, 16, 20. These 5 key values are distributed between bucket A and bucket A2 with respect to third bit. So means 2 bits are not sufficient to distribute, so we have to use third bit. Now to redistribute entries across the old bucket and split image, we consider the last 3 bits. How many bits we have to use? Last 3 bits. If the last 3 bits are 0, 0, 0, it is in the bucket A. If the last bits are 1, 0, 0, it is in the bucket A2. It means the third bit will decide whether it should go into bucket A or bucket A2, which is the split image, right? Because it is splitted, the number of buckets became 5. So directory pointers are 4, which is not sufficient. Then what is required? Doubling the directory of a pointers. Now, if you double the directory of a pointers, previously directory pointers are 4, now directory pointers are 8. And these pointers, now, these are the key values whose least significant bits are 3 bits. It means to verify whether that particular key is there in the bucket A or not, how many bits we have to use? Least significant 3 bits. It means the split causes that local depth to be increased by 1. Previously local depth is 2, now local depth is 3. Now this local depth is increased to bucket A and bucket A2, which is a split image of bucket A. So that this bucket A is pointed by the directory pointer 000 and bucket A2 is pointed by 100. And this bucket B previously having the directory pointer 01, right? So if I have to look for 3 bits as a global depth, because 3 bits for the global depth, in because only 4 key values in the bucket B and only bucket B there, bucket B split image is not there. So that there are these 4 key values in which some key values might have the least significant 3 bits are 001, or else it might have the least significant 3 bits are 101. That's why 001 and this 101 both are pointing to bucket A only. And same reason for the pointers 010 and 110 both are pointing to bucket C, and 011 and 111 both are pointing to bucket D. Fine. But here the global depth is increased to 3, and for bucket A and bucket A2 its split image local depth is increased to 3, but for the remaining buckets local depth is 2 only. It means if I have to search for 5, what is a binary equivalent of 5? 101. What is a global depth? Global depth is 3. Means least significant 3 bits are 101. So 101, it uses a directory of pointer 101. This directory pointer pointing to bucket B, and it will go to the bucket B. And the bucket B local depth is 2. Then it has to look only 2 least significant bits to locate that key value 5. Right? So means to search for the directory pointers, we have to use global depth. To verify whether that particular key is there in that particular bucket or not, we have to use local depth. Fine. Now, the point is splitting the bucket, is it necessitate to doubling the directory? Is it necessitating doubling the directory? Suppose if I have to insert key 9, if I have to insert key 9, 9 in binary we have to represent as 1001. Now what is a global depth? Global depth is 3, means it uses 3 bits 001. Now 001 pointing to bucket B. What is its local depth? 2. Means only 2 least significant bits we have to use. But it is not about searching, it is about insertion. So that it will go into the B. But is there any empty space? No, it is also full bucket. But how many key values to be inserted? 5 key values. But bucket is having a capacity of storing only 4 key values. Because inserting ninth causing an overflow, then it requires to split the bucket B. Now, what is the directory pointers? What is the directory pointer? 001 pointing to this. But what is the local depth? 2. Local depth 2 means the least significant 2 bits having 01 are there in the bucket B. But totally 5 key values are there. These 5 key values are distributed in this way. So the according to the global depth. So that the third bit it will be used. Whenever a split occurs, it is not using 3 bits. Instead, it is using, sorry, it is not using 2 bits. Instead, it is using 3 bits. It is a meaning that it is going to increase the local depth by 3, and but increasing the local depth by 3 makes the directory pointer to use is 3 bits, but already global depth is 3. Is it required to have a directory doubling? No. So the point is splitting the bucket not necessary to doubling the directory. When we have to double in the directory, suppose if we split bucket B, what happens? Bucket B and bucket B's split image, and the keys whose least significant 3 bits are 001 is there in the bucket B, and 101 is there in the bucket B2, which is a split image of bucket B. Now, what are the points to be noted? The points to be noted is a bucket split does not necessarily require directly doubling. However, if either bucket A or A2 grows full, which is already splitted, and again it is grows full, and an insertion forces a bucket to split, then we have to go with the doubling the directory. It is a meaning that if bucket whose local depth is equal to the global depth to split, then directory must be doubled. You can look in the previous one. Here, this local depth and global depth is same. Now splitting of bucket A requires to doubling the directory. If this local depth is global depth are not same, local depth is less than the global depth, splitting this bucket C does not require to doubling the directory. So what are the points to be noted now? If a bucket whose local depth is equal to the global depth to split, then directory must be doubled. Fine. That is about the cases with respect to insertion. Now we will discuss cases with respect to deletion. Simple. For deletes, the data entry is to be located by using the hash function. Suppose fifth one we have to delete it. Hash of 5 requires the 5 to be represented in binary. And what is the global depth? 3. So using that global depth 3, it will go to the bucket whose directory pointers are 101 and locate that particular key value in that bucket and delete it. Simple. For delete, the data entry is located and removed. If delete leaves the bucket empty, means total bucket is empty, it can be merged with its split image. So I'm not required to maintain empty buckets. So you can go for the merge with a split image. Merging buckets decrease the local depth because you have done A and A1. A is a bucket and its split image. Suppose A is totally remote and both of them local depth is 3, 3. Now all the key values in particular bucket is removed. Means only how many buckets are there? Only one particular bucket. Only one particular bucket means that local depth not necessarily be 2. Local depth is to be not local depth not necessarily be 3. Local depth is to become 2. So means merging buckets decreases the local depth. And if each directory element points to the same bucket as its split image, then what we can do? The directory is going to be halved. Half the directory and reduce the global depth. So means deletion can decrease the local depth and global depth, but insertion increases the local depth and global depth. And insertion may causes directly doubling, deletion causing directories to be halved possibilities. And this is all about extendable hashing, how search is done, how insertion is done. Insertion has a cases, inserting into the empty bucket, inserting into the overflow bucket, insertion causing directly doubling, insertion does not causing directly doubling, even a split of a bucket occurs, and the cases we have seen, and when to directly double. If local depth and global depth is same, then directly double is required. And how to perform a deletion, we have discussed all the cases. And you write the same thing in the examination. Whatever I have explained, same thing in the same flow you write, you will get full marks. This notes you can download. Link is available in the description. Hope all of you have understood the concept very well. If you like the video, do like, share and subscribe and share with your friends. And thank you.